Okay, our next talk is by Issac Sarnoff. Blazar. Okay, Blazar boosted dark matter detection. A new vocabulary word.
Now, electrons, protons, and neutrons were only very recently discovered. And the discovery of electrons accounts for all of the technology that we're seeing here today, including your phone to your computer. Protons and neutrons together account for everything from new cancer treatments to nuclear bombs. But all of these together are less than a quarter of all of the mass in the universe. And if something like electrons that is so little of the world that you can't even see its slice on this map was able to give me the power to call my mom from halfway around the world, imagine what can be done when we find the other 3/4 of the world. Now, if finding it was easy, then we would have done it by now. And unfortunately, we only currently know 3 things about dark matter. There's a lot of it, it's hard to find, and it's harder to measure. So, in order to do it, we have built some of the most complicated machines in the world. This machine, the detector called Xenon in Gran Sasso, Italy, uses 1/3 of a year's global supply of xenon. It is buried a mile deep beneath a mountain to reduce the background noise from regular radiation and other interference at the surface. And it still isn't enough. We still have not been able to find dark matter using this detector. One possible problem is that light dark matter may not have enough energy to produce the signals we need. So what we really need is a dark matter accelerator. But how can we accelerate something we can't see or touch? And that's where nature steps in. Blazars are a potential accelerator for dark matter. Basically, galaxies can shoot protons out from the supermassive black holes at the center. I'm talking black holes between 1 million and 1 billion times the size of our sun. And they can shoot these protons out at extremely high speeds. We hope that these protons can then accelerate, hit the dark matter surrounding the galaxy, and travel the millions of light years to Earth, where they will have enough energy that we can detect them. And so we are hopeful that some of the most powerful objects in our universe may be the key to unraveling one of its deepest mysteries. Thank you.
That's fascinating stuff. So tell us where you're from originally.
I'm from Washington, D.C.
And what attracted you to NYU Abu Dhabi?
I really liked the amount of time with the professors. When I came out to visit, I was just blown away at the level of interaction.
Good. That's what we like to hear. That's what we like to hear. Yeah, I'm not surprised. So it's really interesting for you to hear about this. Are there particular black holes that you're sort of targeting to be able to do this acceleration?
Yes. So we are looking at specifically blazars, which means that the black hole has to have a jet, and the jet has to be pointing at us. Otherwise, it would be accelerating these out some other direction, and we might never see it. And it has to be very well characterized. So the one we're looking at specifically is called TXS0506.
How far away is it?
Far.
Very far. farther than I could ever imagine, I'm sure. Yeah. Okay. And have you been to this place to
TXS0506?
Yeah. No, to Xenon. You had all that time with your professors. I figured you were on route.
The travel budget here is good, but not that good. No, yes, I have. I went and I worked for about a month at Xenon over the summer, helping manage the detector and basically fix problems as they came up.
And what was that experience like?
It was really fun.
So there are people just from NYU Abu Dhabi there, or were you part of a big research group?
No, as I say, it's an enormous amount of Xenon, and so it's actually a collaboration of close to 100 people from more than a dozen universities around the world.
So part of a big global group of researchers doing this.
Yep.
Yeah. Fantastic. Well, I'm so glad you've had this experience, and I look forward to hearing about how you are able to identify all that black matter in the future, so dark matter in the future. So thank you so much.
Thank you very much.
Yeah.